All right, we are going to look at the relationship between the rotational speed of an object and the linear speed of that object when it's rolling, like this. So how we address this issue is we're going to look at two frames of reference. The first frame of reference is the one where the ground is stationary. Okay. So the ground is not moving, but it does see that the center of mass of that wheel is. This point is moving. So how do we account for how fast this point is moving relative to the ground? Well, the nice thing is if I can look at this as a rolling without slipping situation, meaning it's not spinning like this, okay, but it's rolling, this point on the bottom is in contact with the ground, and it's not sliding side to side. So what that means is these two are connected. These have the same frame of reference. So what I really need to do is I need to figure out how fast is this point moving relative to a point in contact with the ground. Okay? So take a second, and we're going to look at a different frame of reference and come back to that one. So we're going to look at the frame of reference of the center. So the center sees all the points around it moving. Okay? And so I see this point over here moving at a speed v, which is equal to the angular speed times the radius of that point. Well, if the center sees this point moving this way with a speed, let's say 1 meter per second, this point then will see this point, the center of mass, moving the opposite direction with a speed of 1 meter per second. So if I can find this v to be 1 meter per second, that automatically then means that VCM is 1 meter per second. And so what we end up with is we end up saying that the velocity of the center of mass of my rolling object, and we just use center of mass for uniform objects here is where I'm talking about, is equal to the angular speed of it times its radius. And so we could do a quick example here. So let's say I got this wheel rolling, and I had it rolling at 5 meters per second, and it had a radius of, what did I say, diameter of 0.4 meters. Okay. So if it has a diameter of 0.4 meters, that means it's 0.2 times an angular speed, which I'm trying to find, and it's moving at 5 meters per second. So I just need to go ahead and solve for omega. And so I have 5 divided by 0.2, and so omega comes out to be 25 radians per second.